things because like we don't have enough words. A polygon, there's a polygon. There's another polygon. There's another polygon. It's any closed shape. So when we make this graph, it's going to be a closed shape. Okay, so we still start with a frequency distribution table, but I'm not going to get you to give you a bunch of numbers and collate it. I'll just give you what you got yesterday. Okay, so yesterday we'll use the same data, and what was that again? Yeah, it was someone's marks. Whose marks were they again? Oh yeah. Okay, so our ranges, this was yesterday, was 20 to 35. We decided to round down to 20. We round up to, Antonino, please, quiet. Okay, we rounded up to something, and it was just nice round numbers to work with. That's the reason we did that. So 35 to 50, and 50 to 65, and then we went 65 to 80. They all went up by 15s. And then 80 to 95. Make sure it all covers the numbers you're looking at there, and even if they're decimals and things, okay? Because obviously you can't graph 15 using those intervals. It's not going to show up anywhere, right? So you have to first make sure those are all included. So this was, sorry, who was that again? That was Trish, wasn't it? Was it Trish's grades? Ben's. That's okay. Yeah, thank you. I know you said that. I just wasn't listening. So Ben had one test in there. He had two in there. And then he had two in there. And then he had 1, 2, 3, 4, 5. And again, if you want to write 5, it doesn't matter. You can do it either way. But if you're tallying up, like maybe on your project tomorrow, if you got like 15, well then you're going to go 14, 15, and it gets kind of messy. So that's why the tally method can be nice. But I can't tell you how to do your graph. Either way, your choice. Okay, and then he got a really good test, 1 there. But think, if you got a bar graph like you did yesterday with a histogram, what if you had more than one student on there? Well, you could do about double bar graph, sure. What if you had 3? Triple bar graph. You could, all right, and you'll see it in the real world, but this way is a little nicer if you get more than one thing to graph. So that's the difference. Okay, so Ben was there. Who can I pick on here? Oh. Because it's Thursday, Sydney didn't score anything from 20 to 35. That's a good thing, right? Yeah, that's a good thing. All right. And she didn't get anything from 35 to 50. Can we guarantee she's passing if she wrote all the tests? Yeah, because that must mean all these tests must be 50 or above. So she got 1 there, and then she got 8 between 65 and 80. Okay, Mom was happy. And then she got 3 between 80 and 95 before the course was finished. Now, one thing I don't think I said yesterday, but most of you kind of clued in. This was how many different marks yesterday? It was 12. Now, how do we know that? Does this add up to 12? 5, 6, 7, 8, 9, 10, 11. I'm missing one. Let's put it there. Make it 6. Okay? You got to make sure you do that. All pieces of data have to be accounted for, otherwise the graph is not accurate. And that means you're going to lose marks, right? So there were 12 marks yesterday. There were 12 tests that were recorded. Is this add up to 12? Did she do all 12 tests? If not, she's still got one to do. Kind of like this other girl over here. Got a few to do. Okay? So you got to make sure all your data is there before continuing. Whether you're doing a histogram, whether you're doing a frequency polygon. All right, so I could have 3 students, 4 students. I could have everybody on the class on this one graph. It would be a little cluttered, but I could do it. I'm just going to stick with 2. Okay? If it's more than one, we're not going to try to trick you and give you 3 sets of graphs and say make a histogram. Okay? We'll say make a histogram or make a frequency polygon, not a polygon. If it says histogram, it's only going to be 1. Okay? I'm not going to trick you. But if it says do a frequency polygon on your test and you guys make a histogram, sorry, how much marks can I give you for doing the wrong thing, right? So, what goes where? That's the tricky part here. Which is X, which is Y? Because again, if you graph it the wrong way, well, I don't know if I'm even going to give you any marks at all. Okay? Usually, like I said yesterday, when you graph stuff in the past, I don't know if you noticed in grade 10 when you had all those graphs, but I'm not going to say the word always because then you'll find one that, you know, contradicts me, but X is usually, should be 99.9% of the time on the left and Y is on the right. Same thing. You remember graphing this yesterday? These were the intervals. These were the groups. And those were always on the X. Okay? The frequency goes on the Y. Remember me saying that? This is how frequently Ben got marks in that range, or Sydney got marks in that range, etc. Okay? So the word kind of fits. How frequently did they get test scores in those intervals? Okay? So, we do a graph. Okay, I know that's on the X, those intervals. I'm going to put them down there. I'll break it so I can just start at 20, 25, 30, 35. There's that first interval. 35 to 50 is the next interval. 50 to 65, 65 to 80, 80 to 95, and that's it. Over here, what do we have to go up to? What's the maximum number I have to go for the frequency, which is on the Y? Yeah, 8. And make sure, I told a few of you guys yesterday, I think I told you all, label the axes. What is this? If you're going to lose marks on your project tomorrow, if you don't, okay? Got to know what you're graphing. So I need to go to 8. So can I go by 2s? 1, 2, 3, 4, 5, 6. Ooh. Nope, I can't. I'm just going to go up by 1s, just because I got graph paper. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, not as big and nice as it could be, but it'll do. Now, hang on. Yesterday we did bars. We would have went like this, but don't do this. Ben 1 from 20 to 35%, right? I'm just going to dot it to show you what we did. We're not doing bars. A frequency polygon, we're going to do dots. Where do you put the dot? It's like a line graph. You put the dot right in the center of where that bar would be. Okay? So there is one test score that's between 20 and 35%. He got 2 between 35 and 50. That's put it right in the center of that interval. Visualize the bar if you want, but this isn't a histogram. We don't want bars. 2 from 50 to 65. 6 from 65 to 80. I don't know what it said yesterday, but it's got to add to 12, so let's just put it in there. 1 from 80 to 95. Okay, so you've done line graphs before, grade 8, grade 9, grade 10 you did graphing. It may not have looked like that, but you definitely plotted points. Next, I'm going to join them. Connect the dots. Now, is that a polygon? I erased it. Is that a closed shape? No. So we want to close it. How do I do that? By dropping this one to the next interval just down on the ground. Okay, so the previous interval, just drop it down to the ground. Okay, it might seem weird, but that's what we do. Drop beginning and end of graph to x-axis. Okay? So that now it is a closed shape. If you think of a straight line along the x-axis, it's a polygon. Okay? So that's just one thing. I got another one to plot here. If you got colors, change them. And if you don't, well, you can dash one, make the other one bold, make one thicker, one thinner. Okay, there's lots of ways you can do it. Sydney got 0 between 20 and 35. So there's a dot right there on 0. And she also got 0 in the next interval, because she was a good kid that day. And then she got 1 between 50 and 65. Almost all of her test scores are between 65 and 80. Okay, and high C and a high B. There's like 3 letter grades there. That is way up there. And 3 between 80 and 95. Nice. High B, low A. We don't have A pluses in this part of the world, but in other places they do. 1, 2, 3. Okay, so there's her data, all 12 tests. What do I want to do next? Make a polygon. But it's not complete. It's not closed. So just like I did before, drop this down to the x-axis to make sure it's a polygon. This one's already on the x-axis, so I don't have to drop it anywhere. And that also makes a closed shape. Don't shade it in and color them like I did, because it'll look awfully messy and you won't be able to tell, right? Unless you got really, really light ones. I'm just trying to emphasize the difference between the two polygons. Okay? So, let me get rid of that yellow stuff. Hopefully that's all I get rid of. Okay, so if you just got a pencil, you can still do this, but you have to, if I'm marking this thing, I have to be able to tell which one's which, right? So like I say, you could have just dashed this one, all right, or just made it thicker. Okay, there's lots of ways to distinguish between the two, and you might have questions that have 3 or 4 on there too. Okay, make sense? Frequency polygon, different than a histogram, all right? And if you have questions as to, just don't do the graph backwards. A couple of them are confusing as to which is X and which is Y, because maybe that isn't first, maybe you're getting a graph that looks that way, and maybe they have more than one column. Which is X and which is Y. Okay, just ask me before you start doing it, or take a quick peek in the back. It's okay too. All right, could I plot even more sets of data on that thing? You betcha. Okay, that's when we use, let's put it down here in writing, I said it, but when do we use a frequency polygon? Well, just let's say more than one, because then it covers all the situations. That's like the range question I was telling you about in the first day. Don't forget that. That might be the easiest mark on your test if you remember it. When we have more than one set of data, I'm not going to say the word always, but usually we're going to make a frequency polygon. Okay? So, summary of what I just said the last couple of days is on page 220. You know those green summary boxes I keep telling you to look at and read and review before your tests? Okay, good stuff. And then 2, 9, 11, 7. Yes, those are in the right order. 7's a trickier one, okay, as to which is X and which is Y. Same page. Well, 221, I guess it is, right? Same as yesterday.